So in the last video we mentioned that now is the time to learn how to calculate standard cell potentials. So I'd like to go ahead and show you how to do this. So in our last video we wrote a cell. We wrote a cell diagram that looks something like this. And we converted this to a drawing so we would know how to build it in the lab. Now we can measure the cell voltage here, so E cell. In fact, because we're under standard conditions, our solids are pure and our solutes are at 1 mole per liter, we can write E cell standard here. All right, how are we going to do this? Well, it turns out we can think about it as the electrons are being pulled towards the right-hand side away from the left-hand side. So the flow of electrons, if you like, is going from left to right. Let's just remember what's actually going on here. On the left-hand side, we've got the anode, and the anode is where electrons are being lost. And on the right-hand side, we've got the cathode, and that is where electrons are being gained. And so we can basically make these two electrodes fight for the electrons. And we're going to go ahead and just like electronegativity differences, we're going to go ahead and we're going to say that the cell's voltage, okay, the amount of energy the electron have when it moves from one side to the other, is going to be equal to something on the right-hand side minus something on the left-hand side. So we're going to design this equation so that this represents the pull of electrons. It's kind of like the electronegativity number towards the electrode, and we're just going to kind of pit them in a war against each other. All right, so the right-hand side, remember, is the cathode. So that is E cathode, okay, minus E anode. And these things here we're going to refer to as standard electrode potentials. And all we have to do to calculate cell voltage is look up those standard electrode potentials. In fact, for now, I'll just go ahead and tell you what they are. So it turns out the standard electrode potential for this electrode is positive 0.80 volts. And whenever you see a very positive one, you know that it's going to do a good job at pulling electrons towards it. Okay, if you look up the standard electrode potential for the copper one, it is positive 0.34 volts. So they're both actually pretty good at pulling electrons one towards the other, but the cathode is a lot better than the anode. So if we go ahead and we calculate that difference, we get positive 0.46 volts. So if we hook this cell up to a voltmeter, we would get 0.46 volts. And it turns out that that voltage is a measure of how much energy the electrons are pinging from one side to the other. So you can think of it like a waterfall. So you've got a waterfall and you've got one electrode, the anode here, and the cathode here, and the electrons are falling down. So the bigger the gap between them, the more energy they fall with, the more energy they've got to, make a light filament hot and bright, let's say, or whatever you might be using your energy for. So in the next video, we'll look at where to find these standard electrode potentials. We'll look at how they're tabulated. And we'll look in a little more detail how to calculate the overall cell voltage and what the overall chemical equation is. So stay tuned.